Okay, so real quick, a couple things here. So they talk about a perfectly elastic collision. What does that mean? That's an important word. Perfectly elastic collision.
Nothing's lost.
Okay, it means it's very bouncy. In fact, it's so bouncy that what? Say it again. No energy's lost. Yeah, energy's conserved. Okay. So then that's what makes this doable, because if kinetic energy is conserved, and what else is obviously conserved in a collision?
Mass.
Well, mass, yeah. But what else do we always know is conserved in any, even if it's not perfectly elastic, even if energy is lost, what's always conserved in any collision? What? Well, I mean, yeah, but that's not the quantifiable term. Well, yeah, momentum, which is just the quantifiable version of inertia, right? So, yeah, so momentum's conserved, kinetic energy's conserved. That's enough for us to solve for both of these two unknowns, right? Because really what we're doing here is two equations and two unknowns. These can get pretty tricky if you're not given the right information, but I'm giving you the right information. So it makes these pretty simple. So the
So my problem was I forgot to pass by order.
okay, so I think I was supposed to say the first one is at rest. I'm pretty sure. Let me make sure. I wrote these the other day. I gotta look at this real quick, just make sure. Hang on. Oh my gosh. End of the year is so hectic. This is so unbelievably hectic. No. Oops. Oh no, it's okay. So it's not. Never mind. Yeah. So the other one's not at rest. Strike that. We don't need it to be. We don't need it to be.
So it's good the way it is.
Yep. We're
All
good.
right.
Yeah, we're good. Did I move this onto the? Yeah, I did. Okay. So, all right. So then, what do we know about this? I give you the masses. I give you the initial and final velocities of the first ball. So what can we do? And we're just trying to solve for V2 and V2 prime, right?
Yes.
Okay. So what's one equation that I can definitely write?
Kinetic energy. We write the kinetic energy, right?
Okay, so one equation is going to be because of the conservation of kinetic energy, right? So I could say that 1/2 times first mass, which is, I'm just going to suppress the units, right? We're just going to use regular units. 1/2 times 12 times V1 squared plus, oh wait, we know V1, don't we?
Yeah.
Yep, 14. Oops. Plus 1/2 times M2 times V2 squared equals 1/2 times M1 times, which is 4, positive 4. That might be negative, by the way.
Wait, do we have, does it matter?
Because they're defined in terms of the positive x direction.
But it doesn't matter
So
if you're
negative would
squaring
be
it.
backwards, right? Say it again.
Would it matter if you're squaring it though? Since we're squaring it, does it matter?
It's going to in the other, it's not in this one. Oh, you're right. There we go. Times V2 prime squared. So those are my two, let's make those red. So those are my two variables, right? Okay? I mean, there's one equation, sorry. So there's the equation with conservation of kinetic energy. What's the other one we can do? No, no, no. In a collision, momentum's concerned. Right. So we can just do MV1, so 12
Like it for
V1, which is 14. Whoops. Plus 10 times V2 equals 12 times 4 plus 10 times V2 prime. Once again, let's go ahead and make those red. So what do we do to solve that? Well, there's a couple things we could do here, right? We could multiply, we could simplify all those numbers, right? In fact, we could divide, we could multiply by 2 and get rid of all the 1/2. That's a good idea.
wait, so we're using both equations or just?
Yeah, we have to use both because we have 2 unknowns,
Oh,
right? Okay, and then we've got, it looks like all those coefficients, we could divide everything by 2,
yeah.
right? All terms by 2, make that a 6, that a 5, that a 6, that a 5. And that makes things, that actually helps a little bit, right? That makes things a little easier. So equation 1 then, let's just call this equation 1. Equation 1 is going to become, what is 14 squared, 196? So
Wait, is it?
6 times 196 is 44 for 1200, so 1176 plus, better check me on that too, plus 5 V2 squared equals 16.
Yeah, you had it right.
Okay, so that's 96. Check me again. 6 times 4. That is right. 6 times 16. Yeah. Plus 5 V2 prime squared. Okay. And then down here we could divide everything through by, looks like maybe by 10 again, or by 2 again, right? Okay, and so then we're going to get, for equation 2, we're going to get 6 times 14, so that's 84, plus 5 V2 equals 24, plus 5 V2 prime. Can we close the door? Why? All right, so we can, let's go one more step then. So we can take equation 1. Actually, let's take equation 2 first, because that's the one that's going to be easier. How do we solve a system like this? Substitution, sure. So we'll use the second equation as the substitution equation, right? Okay. And let's talk about, you know what, let's talk about how you could do this more easily on a calculator. Because I think the question is asking you to,
But, so we have to solve for either V squared or V prime, or V2 or either V prime 2, and then substitute.
right. Okay, let's set this up once algebraically, and I'm going to show you a trick for solving this system much more easily. Okay. So we could, if we we solve this one for example, how about for V2 prime? V2 prime, if I subtract 24, I'm just gonna get 60 plus 5 V2 over 5. I think I set these things up so they work out pretty nicely. So that's equal to, what, 12 plus V2 equals V2 prime. Everybody agree? I could subtract 96 from both sides here. That would make things a little bit easier. So that's going to give me 1080 plus 5 V2 squared equals 5 V2 prime squared. I could divide everything by 5 also, couldn't I? Right?
Are we
So-
just saying substitutes, easier to substitute?
Yeah, that's all we're doing. Right, so I'm just taking equation 1 and rewriting it. So if I divide 2 by 5, I'm just going to get 216 plus V2 squared.
How'd you get the 1080? I'm sorry.
I just subtracted 96 from both
Oh,
sides.
okay.
Equals V2 prime squared, which is just that, right? Everybody see that?
Yes.
Okay, so that's just equal to the quantity 12 plus V2 squared, right? Question?
No.
You good? Okay, so then if we boil this out, this is just gonna give us 144 plus 24 V2 plus V2 squared. Right?
Yeah, and then we just solve for.
Right. And then we can subtract those away. And so now we're just solving for V2. So subtract 144, so 24 V2 equals,
If you can do that independently, but. Oh, wait, actually,
I think
28.
I think it's gonna work out
200.
fine, honestly. 56 plus 16 is 72.
72, yeah. Oh.
So it's 3. So it works. And if V2 is 3, then it's nothing for us to find
And
V2
then we
prime,
just put it,
right?
and then
15.
So I actually, and that was no easy thing to do. I actually worked these out so they come out fairly nicely.
thank you.
You could also, what if you called like V2 prime Y and V2 X? Can you think of a graphical way to find this solution?
You just solve for y.
Yeah, you could, right? You could just solve for Y in terms of X in both cases. See what I'm saying? Solve for one in terms of the other, and then just graph the equations and look for the intersection.
And you just want to be
No, you need both. You need both, because like, for example, if we did that, we got them simplified.
So when we set
Where are
them
they
equal to
simplified?
each
Like,
other,
right, where's our easiest version?
216, it's right, that second.
Right, so this is a good one, right?
Oh, yeah.
Well, this is a
That
good
one
one,
you want,
yeah,
that one.
and this is a good one. If we graph those two, let's just call V2 prime Y, right? So then would you agree that this is just gonna become Y equals plus or minus, but obviously the plus, right? Yes, I should say that.
Let's see if it works.
Y equals, I guess you'd have to do plus or minus. Plus or minus the square root of 216. So you have to graph them both. That's fine. So you're graphing three functions, the plus, the minus, plus x squared. So there's one equation, and the other one would just be, right here would just be y equals x plus 12. Okay, and you look for the intersection. Should we try it?
Wait,
Did I do it wrong?
no, you're fine, I'm talking.
I mean, and, you know, I'd like you to try this one, but it's not like you have to do this one again. Easy real test, you know. What's that? Yeah. Yeah, is this thing? Oh, yeah, I guess it wasn't. Yeah.
Wait, shouldn't they all intersect at the same spot? No.
No.
The negative one, that one's, one of them's not gonna be right.
Right, one of them's not gonna be right,
So
exactly.
how do you determine that?
You just graph them and see where they intersect. You're gonna see that only one of them is clearly gonna intersect.
Okay.
You understand, you guys see why, maybe, if we were to look at this equation right here, this is really just y squared equals 216 plus x squared, right?
Yes.
Okay, that's not a function, is it? Right? That's gonna be, it's a relation that's not a function. It's gonna be, what it's actually gonna be is a circle centered on the origin. Okay? With a radius, actually, no, it's not. It's gonna be
Yep,
a,
got it.
yeah, it's gonna be a parabola,
But y equals 15, I think I tried.
or it's hyperbola. What's that?
Nothing. It just goes x equals 3, y equals 3.
So it tells you that?
Yeah.
Tells you x equals 3 and y equals 3, yeah. So if we graph, just so you guys can see this, first one is positive square root of 216 minus x squared. Did I mess it up? Oh, plus x, whoops, never mind. Okay, next one is minus square root of 216 plus x squared. Oops. Delete. There we go, okay? And then the last one is 12 plus x. Okay, let's just go from, make our window go from negative 10 to 10 to start with, how about? And just go zoom fit. So zoom 0.
Is there any way we can tell that we don't need the negative one?
So there's my hyperbole. What's that?
Is there any way we can tell we don't need the negative one?
Does yours get to be different colors?
Pretty fancy, huh? You know, the only way you can tell you don't need is if you zoom out, you'll see that those are never gonna intersect.
No, but I mean before we put it in the plus and minus. No, we can't. Algebra.
Yeah, there is.
Okay.
There is. There is a way you can tell. You could even tell me, just tell me why, if you read this problem, if the first ball is traveling in the positive x direction, when it smashes into the other one, right? And it ends up going in the positive x direction, then the other one has to also, right?
Yeah.
Does that make sense? Okay.
So it just,
Mhm.
okay.
Yeah, but you won't always, that's just because of the numbers that happen upon the period. You wouldn't always be able to know that necessarily. Okay. So you'd have to just look at the graphs, but they should only intersect once.
Okay, and then so the 3 we then take in and plug back into the first
Right
equation.
there. So you get the answer 3, 3?
I got 315.
15, that's right, yeah.
Oh, and 15 we
See how that works? But you can do this one algebraically. I don't think on these calculators, unfortunately, don't really do that much. The Inspires and the 89s do. Then you can solve stuff symbolically. And you can do more things. I don't know that you can solve. Try one more thing, just to make sure. So if we go apps. Right there. And we go polysmoke 2. This is a simultaneous equation solved for also. So we'll see, I've never used this, but we'll try it. 2.
Okay, so wait, once we find the 3 and the 15, and it says, the velocity of the 10-pound ball after the collision is.
Yeah.
So then where do we put the V?
Well, so then after would be V2 prime, right, so it'd be 15.
So it's just.
Okay, so let's try this. 2 equations, 2 unknowns. Oh, it's only for linear equations. Oh, this is lame. That's not that good. We do that with linear.
Alright.
Yeah, that's a good deal.
Can we hit forward?
Yeah, go ahead. We're good.
I mean, you only have 13 minutes.
That's okay, we're still good.
That's, can you get me one through
I
that?
don't know if the other solver is in C. I'm
Can
gonna
you
mess around
find
with
meters
this.
per second from watts and newtons?
Solver. Oh, this might be good. Huh. That's like a pretty easy way to do it. So we don't even,
Does the substitution for you, doesn't it?
yeah, I think it does. And so I don't think we have to, I think we can just leave it as,
Right there, 1 and 2.
oh, but it's only gonna do it for one variable. So you are gonna have to put in all of them. See what I'm saying? You gotta solve
Yeah.
explicitly. Yeah, this is pretty limited, this one. I mean, this will still work. I just wanna try this and make sure it does what it's supposed to do. So we had here square root 2 6 plus x squared. I don't know how to do, I don't know what they want me to do. Google it. Kinda like to know.
First, we're coming out of 5 meters per second from watts and newtons.
Hmm?
I said, can you tell me how to find meters per second from watts and newtons?
Meters and seconds from watts and newtons. Well, watts are just units.
Yeah.
Units of power. That's what's important is power is just the rate of doing work. Power is just work over time. Or force times speed. Same thing.
Yeah.
There you go. That's how.
I don't know if I got all these 5 times.
Force times speed.
Yeah, if it's constant speed.